How's everyone able to see this in the back? Good. Well, you can't actually do anything about it. So, what I like to talk to you about in this first topic is the different aspects that you're going to start thinking about in this class that I think it's important to distinguish between. So let's talk first about programming and what that means. So how I define programming, it's the way that a human communicates with a computer. So you have something that you would like to be calculated or done or written, and programming is the way that you communicate what you as a human want a computer to do. So what do humans use to communicate? They use words. They use a language like English. What do computers use? Binary. That's the only thing a computer can do. Luckily, we don't have to write code in binary. MATLAB has already gone from binary to MATLAB syntax. But we still need to make that connection between MATLAB language and human language. So programming is the interpretation from one to the other, from a programming language like MATLAB to either the beauty of mathematics or words or however you want to think about it. So programming involves the use of variables, loops, conditional statements, data structures like where you store all your data, basic arithmetic like addition, subtraction, multiplication, division. So that is all the stuff that we're going to be learning in this topic basically, is some of the simplest forms of the programming language like that. So that is probably the number one thing that we hope that you gain from this class, is the skill of programming. And you'll notice that it's a skill that's not dependent on any particular programming language. So the next thing, which is is there a term like the bane of my existence? Is that a thing? Is that the way you say it? I don't know what that word means. But that's what syntax is for most people. It's the picky things like, how do you spell that variable? How do you spell that function? What inputs does this function need? Do you need a dot here? Do you need a semicolon here? That's the syntax that's required for MATLAB to understand what you're saying. And so this is the language specific to MATLAB. In which you write your program in. So the way that you write in MATLAB is not going to work if you write it in C or Fortran or any other language, but you know how to program, you just need to learn a different language. They're two totally different things. So you'll hear me all the time say, when I come over to your computer when you have a question, I'll say, oh, that's a syntax issue. And I say that to make it very clear that, listen, you know what you're doing great, but your syntax is off. And it's just, it's just like a thing that you have to keep working at and keep remembering to, I guess it's one thing is that you need to learn how to know how to figure that out, like go into the help and figure it out. It's the one thing that I do not emphasize on exams, syntax. I will have some syntax-oriented things, but I'm not asking you to memorize every single thing that you need to write MATLAB code. But in order to write MATLAB code, you have to have the right syntax or it will not work. So let me give you an example of this. So I talked about in programming, you use loops. It's a structure that we use in almost every single code that we write. So in MATLAB, the syntax for a loop, there's two kinds that we use, a for loop or a while loop. And you need to understand that exact syntax in order to write a loop. For conditional statements, for example, that's a general programming concept, and in MATLAB, they're called if-else constructions, and the syntax is if-else, end. And then same with like if you need to do a relational operation, how do you write the greater than symbol? How do you write the not equal to symbol? Those kinds of things. It's the worst and the best syntax. Okay, the third thing is logic and algorithms. A huge part of this class is that I want you to be able to develop your skills in both logic and how to develop algorithms. And the way that I specify this from programming is it's a general stream of logic that solves the problem that is not dependent on a specific language. So for example, let's say I asked you to write a code that says, write a code that can guess your age. So you understand the problem. This code should somehow prompt the user to give some sort of input, and then the computer will randomly guess until it guesses your age correctly. You understand the concept, but how do you then translate that into logic and an algorithm that actually does that? So there's this sense of logic and algorithmic ability that allows you to do that transition. And then the last thing is that MATLAB is so much more than just a programming language. It is a whole software package. And this is not a class. This is not a training class on how to use MATLAB, right? So if you just needed to understand how to use a software package, you could go to that company and take a training class on how to use their software, right? How do you use their modules? How do you use some of their toolboxes? There's so much to MATLAB. However, by nature, we're going to learn how to use a lot of it. So what I like to call MATLAB is it's a computing environment. So it has plotting capabilities. It has a whole analytical toolbox which can help you with like calculus problems. It has hundreds of toolboxes that are used in other engineering classes. And it's also just a calculator, right? It can completely replace your calculator. So this is like the bare minimum of what I hope that everyone is able to do after they leave this class is use MATLAB as a tool to just make your life a lot easier as an engineering student and as an engineer, okay? So I hope this kind of like breaks it down a little bit of like what all is involved in this class. So moving on to our topic 1, MATLAB basics, and what you're going to cover in this topic is we're just kind of going to explore all of these areas, I would say, and it's particularly focused on area 4 is getting familiar with the environment. That's what I'm going to show you today. So I'm going to switch back and forth from my screens here, and I'm going to try to keep your notes updated. Does anyone know what MATLAB stands for? Yeah, that's right, Matrix Laboratory. So it's called that because everything in MATLAB was designed to operate on arrays, matrices, vectors. It's one of the few languages that's written that way. So instead of doing things one at a time, MATLAB excels when you do things to entire arrays at a time. And we touched this topic a little bit in this class, which is called vectorization. It's rewriting your code so that it's much, much faster. And so that's why it's called that. So let's talk about some of the things we're going to look at here. So let's first just get familiar with the windows in MATLAB. So this is what MATLAB looks like. And you're going to repeat some of this in your pre-lab, but I can't really start showing you until I give you a quick tour. The command window is where you can execute commands one at a time, like one-line commands. So this is if you needed to do any calculator replacement, like if you just need to use it like a calculator, you do it directly in the command window. You type out anything you want, press enter, and it executes the command. The command window is only used to try things out or to replace a calculator. Anytime you're writing code, you're going to write it out in a M file, which is an executable file, so that all your code gets executed at once. So that is particularly true for this first lab. I feel like everyone starts doing it in the command window, and then all their commands are just one by one in the command window, so you have to keep going back and re-executing them. So just know that this is just kind of a place to try it out. So this is the command window. The other folder over here called current folder shows you what folder you're running the files from. So why it's important is if you're running files that you've written, you have to be in the folder where the file is stored. So I'll show that in a second, but just so you know, you should always create a folder and run all of your files from that same folder. People do this very differently. A lot of people are bringing in jump drives for the lab computers and just running off their thumb drive. Some people are running off, is it the Z drive? What do you call the Z drive, which is fine to do. I would not run off the local computer because I think it actually removes all the files every day. Is that correct? I don't use the student computers, you know, but you need to create a system that works for you of where you're going to keep your files. I don't recommend emailing yourself the files every time. There are better ways. I'd like to introduce you to Dropbox or Box through the university or Google Drive. Like, use something, okay? This here is your workspace. So if I define a variable, which I'll talk about in a second, like the variable A, you'll see that once you execute that command, that A variable shows up in the bottom left-hand corner. Can you guys see this okay? Okay. In the workspace here. So what shows up in the workspace is anything that you execute in the command window that MATLAB knows about is going to show up in this workspace. A couple other windows that are important is your command history. Your command history sometimes is not loaded automatically. Apparently it wasn't for mine. But every command that you put in execute will show up in your command history. So that way you don't have to retype things out. In fact, if you just double click on something, it'll just re-execute that command for you. And one thing that you really need to get used to is not retyping things as much as possible. And it actually goes back like forever. And it's dated, it's really, really useful. So even when you close MATLAB, your command history is still saved. A couple other folders. So if you click on this button right here, New Script, that will bring up the M file writing window. And so this is where you would write out a list of commands that you want all executed at once. Otherwise, if I wanted to redo commands, I'd have to re-enter them every single time in the command window. So once you start writing enough where that's getting annoying, then you're going to move over and put those commands right in to the command window. And then when you press run, it'll run all of them. So I'm going to save this file as test.m, and then when I click run here, it's going to execute that file in the command window and run everything that's in that file. And so this is called the text editor. I don't know, I might have made that up, but something like that. And then the only other window that I asked you to be familiar with is the figure window. We haven't started plotting yet, but once you start plotting, there'll be a second window that pops up that will put any plots into. And so I got this to pop up by just typing the word figure, and it opened a new figure for me. But what this will do is it will just, I can just show you something really quick. Oh, do I have a sub? Why is it doing that? Okay. Okay, it's a mystery why it's going into a subplot, but if you have your plot open, there's actually a lot of, this is called a GUI, graphical user interface, but it has a lot of buttons that you can push. It's not code, so that you can like add stuff to the plot. Like you can add like a little marker, you can change the line color, and it's all just visual. We will never be creating plots this way, but just so you know, if you're doing something quick and you just wanted to check something, there's a lot of options just within the plot. Okay, so let me move on to just using MATLAB as a calculator in general. So for example, you can do any sort of arithmetic in here. What we typically do, I'm going to close this, a little more space, is a lot of times we're going to work with variables. So that's kind of how your first lab is you're going to set a bunch of variables, and then you're going to create calculations based off of those variables. And the reason that we do that is so if you wrote this in a command window and you wanted to change x, the value of x, it'll just re-execute everything below it with the new value of x. But I just wanted to show you this in the command window. Here you can see that I created 3 variables. 2 I set, x and y I set, and then z was calculated based off of x and y. So you'll notice that here, if I change the value of x, it'll get changed, but it's not automatically going to update the value of z because z didn't get re-executed. So you have to go back and re-execute z. But you can do a lot of things. Just like you can do in your calculator, all the trig functions are there. The different like irrational numbers like pi, exponent. An exponential is exp, and you have to give it a number. So exp of 1 is e. All the trig functions are there, like cosine. Cosine, by the way, is in radians. If you want to do trig functions in degrees, then the function is cos d. So as you can imagine, like I couldn't show you all of these things, but know that anything that's in your calculator exists in MATLAB. You just need to go to the help and search what the syntax is for that function. So that's the first thing that you'll kind of explore in this topic. Let me just tell you about a couple different shortcuts that are very, very important. The first shortcut is if you want to execute a previous command, you can use the up and down arrows. That's how I'm toggling through my old commands. So a lot of times what you'll do is you'll put something in and you'll have a typo or something. Instead of retyping this command, just go up, edit, and re-execute. So up and down toggle for your previous commands. It's much more useful than your command history. I would use the command history if you need to go back quite a bit instead of toggling up that much. The second one is the tab command, the tab shortcut. So let's say that you wanted to use a trig function, but you weren't 100% sure, but you guessed that you could probably get pretty close to the function name, like tangent. You can start typing the function name and press the tab key, and it will auto show you every command that fills with that function. And then if you even guess it and you see it's listed here, then you can be pretty sure. And then you can even just go into the help and see what that function is. So I saw that there was a function called tan, so I can assume it's tangent. So I could just type help tan. And you can see that it explains that it is the tangent. So that's the second tip, is the tab command. The second one is this is the most important command, the shortcut that you have to have down. If you start typing something and you're stuck, do you see how the arrows aren't there anymore? The arrows aren't showing up? It's because I'm stuck in the middle of a command. It's waiting for the rest of this for loop. So it's not going to end until I finish it. But let's say I didn't want to finish it, it was a mistake. If you type Control-C, and that's on Macs and PCs, it cancels your command. So a lot of people get stuck in loops, or happens all the time, and they don't know how to quit it, so they shut MATLAB down and restart it, or they restart their computer. So just know Control-C is what you need to shut it down, Mac and PC. The last tip I have for you, a little shortcut, is if you want to clear out your workspace, which you often do, there's a couple things you can type. Clear is the first thing. Clear is going to clear all of your workspace variables, but it keeps some temporary files or variables. Clear all is a more intense clear. It clears everything. And a lot of times MATLAB will actually say, it will recommend that you don't use that because it slows the code down quite a bit. And CLC will clear, you couldn't even see it, it clears your command window so your commands aren't there anymore so you can have a clean slate to start from. And then the other big one is close all. So if you have a bunch of figures open, it will close all those figures. So typically, all M files should start, the top of your file should have close all, clear all. Some people put CLC. I don't like CLC. I don't like it to clear the thing. But you should always have clear all, close all. Those should always be at the start of every M file. If you don't, you'll see that there'll be a lot of confusing things that you'll get mixed up, close all in particular. Okay. I was telling you about these trig functions like tan and cosine and sine, exponential. What those are called are intrinsic functions. They're functions that already exist in MATLAB that you're just using, you're not writing. So we're going to be using these all the time. So if you hear the word intrinsic function, it just means a function that is available in MATLAB. Okay, let me just talk a little bit about variable names now. So variable names, there's rules for variable notation, variable naming notation. So the first rule that's important is that you cannot start the name of a variable with a number. So here I've called it this variable AB. If I try to do it again and I put a number at the beginning, it's going to cause an error. So variables have to start with a letter. And the reason for that is the letter, the character, indicates to MATLAB that it should search for a variable. Okay? There's no other reason you would use a character in MATLAB. So that's why you can't use a number to start. One thing that you should be very aware of is, let's say I was doing something with a trig function like cos. I was using cos in my code. The scary thing about MATLAB is that I can use cos as a variable name. So I can overwrite the function cos with the number 2. So now that trig function cos does not exist anymore. If I try to plug in like 2 into cos to take the cosine of 2, it's not going to work. Okay? It is the #1 most confusing error message that we see, because this error message does not tell you what the problem is, right? That is not a clear error message. So just be aware that any function that already exists is allowed to be overwritten. So what I would do is, before choosing a variable name for any variable, make sure that that is not already an existing function. How could you do that? The tab. That's what I was hoping you'd say. Just type in the variable in tab and see if it exists, or search the help. If it's some weird function that you're never going to use, go ahead and overwrite it. It's not a big deal. But a lot of people overwrite like the max function. We use it all the time. People overwrite the trig functions. People will overwrite pi. So just be careful of that. Okay, so let's look at this script again. So when you open up a new script, you can click new script. That's the quickest way to do it. You can also click this new drop-down menu, and you'll see there's a couple different options. Until we get to topic 6, all of our M files will just be plain scripts. Once we get to topic 6, we're going to write everything in function files, so we'll start creating functions. So open up a new script, and let's just do what I was doing before. I'm going to create a couple variables. I'm going to do a calculation from those variables. Okay, so this is my script. I've created 2 variables, and I've done a calculation with it. Can anyone guess what the semicolon is doing at every line? Ending the command. Any other ideas? What's that? Yeah, it's suppressing the execution. So if I type a equals 1, it actually shows me what I put in for A. If I put A equals 1 semicolon, it doesn't print it out. So do you think we want semicolons or we don't want semicolons? We want them. We should have a semicolon on every line because some of the codes you write are going to be like 100 lines. If you have everything printing every time, you don't get to see anything useful. And when you start getting loops in there, it's going to print it every time it runs a loop. If the loop runs 1,000 times, it's going to print 1,000 times through the screen. So I'm going to save this as test 2 and run it. So when I ran test 2, what happened? Nothing. Nothing showed up, right? So that's always a little disappointing. But it ran it, and it's fine. And you can actually see in the workspace, G has a value, and it has the correct value, right? But nothing printed. So what you want to do is write all your code, however you want to write it, suppress everything, and then choose what you want to display to the screen. So let's say that from this code, all I wanted to know is the value of G. You can choose to either unsuppress the line G so that it shows. That's kind of like the quick way. Or you can use this function called dis, which is the display function, and it will display the value of G, and it displays it in a little bit nicer way. It skips less lines. It doesn't print G equals. And you can even make it look a little bit nicer. You could put like another display statement above it that actually says that G equals or something like that. You can also put them in the same line, which is what you'll do in the lab, is figure out how to do some of that syntax. You guys have any questions about this M file, how to execute it, how to set variables, how to do calculations, how to display?
No, when you say suppress, what do you mean?
It just means that the output isn't printed to the screen. It still executes the command. And that's technically the term that's used, is suppress the command. Any other questions? None? You're so excited? This is amazing, right? You never thought you'd be able to calculate A times B minus A, right? Now you're like, the world is my oyster. I'm really into these sayings today. Okay, the next thing I wanted to talk a little bit, yeah.
So would you get in trouble if you just got rid of the semicolon on the last G statement?
No, you wouldn't. That's fine to do. Let me show you what it looks like. So as you say that, I'm going to comment out these lines. So if I put a percentage sign in front of the command, that actually makes it so that command is not executed. It skips the command and it turns it green. So these lines are no longer executable. So now I just have 3 lines in my code and the last one isn't suppressed. So as you can see, it just prints out G equals 4. It's just a little bit like dirtier, you know? Like it's not a nice thing to see. So as a programmer, you want everything to kind of come out in a nice way that's really easy to interpret. So if you have one thing, it's fine, to just unsuppress it. But a lot of times we're starting to look at lots of things and print lots of things to the screen, especially because we don't do plotting until topic 3. So before we can plot, we display a lot to the screen to show our results. Yeah. That is the only way to comment. Yep. And MATLAB actually recently has a bunch of new stuff for publishing your code that you can create. Like if you do 2 double comments, it creates like sections of your code so that you can actually only execute sections of your code. A lot of students start exploring this. We don't do it in this class, but that's the only other like different commenting type thing there is. No. If you have a lot of stuff, you can highlight it, right click, and then click comment, and it comments the whole thing. Any other things? I'm sorry that I'm eating these. I'll start coughing if I don't. Any other questions? Okay, let's talk a little bit about different data types. This is also in your pre-lab. So far, everything that I've showed you here is with numbers, right? I've been doing number calculations. I've been doing variables set as numbers. One thing that we do a little bit in this class is we look a little bit with character strings. The reason that we deal with character strings is for 2 reasons. To produce useful comments to the screen and to label our plots. Those are the 2 things we use character strings for. A character string is just words, verbatim text, right? So you can use numbers as character strings. So for example, I could create a variable that has my name in it. So this A is no longer a numeric number. It is a text string. So if I try to do a calculation on it, what it does is it takes each letter, it converts it to a number, because every alphabet character has a number associated with it, and then it does the calculation. It makes no sense. That's kind of why it's scary. But what I could use A for is if I wanted to create a display statement and I wanted a variable for it. If I wanted to use it as a title of one of my plots, see how it says Shannon right here? Something's seriously wrong here that it keeps putting it as a subplot. I'll have to look at that. You see it says little tiny Shannon right there? So that's what we use character strings for. So I wanted you to at least be aware of the idea that you can save variables as character strings or numbers. And let me actually move over to the dot cam really quick to just write some of this out with the data types, because there's a few things I want you to know with data types. So what we just did is, I'm just going to abbreviate it. So we did some shortcuts. That was the tabs, the up arrow. We did intrinsic functions. We looked at variable names. And then we looked at M files. You're going to revisit all of this in your pre-lab and then again in your lab. So again, the more times you do it, the more this will make sense. So right now, there are a lot of different data types in MATLAB. You can have integers, you can have 8-bit integers, 16-bit integers, you can have floating point numbers, but we only use 2, so I like to just focus on them. So the first kind we use is character strings. And a lot of times for character strings, we're going to be using something called a cell array. We're going to talk about it next topic. So just jot it down so you have it if you ever look back at it. But it allows you to put whole words in and clump them together rather than separating every character into a different input. And then for numbers, we use the default number type in MATLAB. And MATLAB's default number type is a 64-bit floating point number. Does anyone know what, just so you know, when I ask these crazy questions, like does anyone know what 64-bit is? I don't expect you to know it, but who knows it? Yeah.
There is 64 places for a 1 and a 0.
Yes. So it has the precision, it can hold the precision and accuracy of 64 bits. So I don't know exactly what it is, but it's probably something like the precision of 10 to the minus 30. Might be 10 to the minus 30 about, I think is what it is. That's how much precision this number can hold. So, for example, if you want to see it, I think this is in your pre-lab. Let's look at let's look at 52. So how could you store the number 52 in some number of bits? So 52 is an integer. So because of that, I'm going to write it out as an 8-bit integer. So that's a lot less than 64 bits, right? So what that means is it's going to take up eight bits. So I have 8 slots here. Each slot can only be on or off, 0 or 1. So the way that it works is you're going to start at the back, and binary numbers use base power 2. So let's say that this one is going to start at base 0 or 2 with a power of 0, and then we'll just go up all the way up to 7. So what's 2 to the 0? That's 1. What's 2 to the 1? Okay, and then we have up by 2 everyone. So 4, 8, 16, 32, 64, and 128. So the way an 8-bit storage would work is you can only turn on and off these 8 numbers, and when you add them up, that's going to represent whatever number it is that you're trying to write with this 8-bit number. So with 52, you want to start at the back, and if you want to represent the number 52, Do you need a 128? No. You need a 64? No. But you're going to need a 32. So if you use a 32, what do you have left? 20. So do you need a 16? Yes. And then you're going to need a 4, right? And so everything else is going to be turned off. So 52, written in binary with 8 bits, is 00110100. That's how you write 52 on a computer. So as you can see, with 8 bits, you're not going to be able to really write much in terms of decimals or any precision. So that's why we use 64 bits, because it allows you the precision you would need for anything that we're going to calculate in this class. 64-bit is the default. So when I did a equals 1, it automatically made that a 64-bit number. Okay, so now you can impress all your friends that you can write in binary.
Is it always 2 now?
Always base 2, yep. Yep. In fact, our system should be in base 2. Base 10 makes no sense. But that is not a discussion for today. The last thing I wanted to talk about today is the problem-solving method. So if you look in your packet, on the last page of every pre-lab, you'll see a list of steps 0 through 5. Now these steps I designed in order to help people who felt very overwhelmed with starting the labs, because they're more open-ended. And so these give you a few steps to kind of get to the solution to the lab. So for example, step 0 is read and understand the problem. So that's what you should do first. And then what I have you do is, the first step is solve it human style, is what I call it, and write down the steps you took. So for example, if I asked you to write a code that had the computer guess your age, I would have you write down the steps of what you would do if you were doing that with a human asking your age. So first you would get a human, and then you would have the human prompt you with a guess, like the human would say, hey, are you 20? And then you, as the user of the code, would have to respond yes or no, and you would just write out those steps of how you would do it in a human, as a human. Step 3 is converting each of those human steps into something a computer could do. So instead of the computer being a human verbally asking you a question, the computer would need to display a print statement to the screen and prompt you with a user prompt for your response. And so you convert each of those steps. Then step 3 is to take those kind of steps that you've converted and write out an algorithm or pseudocode, like put them in the right order. And then step 4 would be starting to convert to MATLAB syntax. So how do you do a user prompt in MATLAB? It's called the input function. And then at the end of those steps, I have you write down any questions you have that you would like to ask during lab. And that's the way that you can get the most out of your lab time, is if you complete all of these steps and have an idea of how you would start writing your code before you come into class. So there's 2 things that you need to do before you come to your lab next Monday or Tuesday. One is you need to finish the pre-lab. You need to come to lab with the pre-lab finished. And then 2, you need to read through the lab and work through these steps. For some of you, you will not need to go through every one of these steps verbatim because you're feeling like you're making the connections a little bit quicker. For some of you, you will. So just know yourself and do what you need to do to be prepared. If you don't do those steps, you're always going to be behind and you're always going to be catching up, okay? So that's the best way to success. Is there any questions? Okay, thank you.